I taught myself the electrical. I taught myself, what else? The mechanical engineering. I mean, it's a lot because this is like every discipline coming together to build this type of machine. So, you know, some people oftentimes might say, it's been done before, which we know this type of machine is unique and one of a kind. But then some people might also say anybody could build it. But I promise you, 5 years in, I'll tell you right now, not anybody could build this. And sometimes even I don't know if I can. You know. But anyway, let's go over how this works, right? Look, so last time I tried to go live on, I'm not even going to say, but you know, this platform, thank you for the donations, guys. Last time I tried to go live on this platform, okay, it was giving me issues and banning my live stream, saying I was directing people to another website. I'm like, okay, what? But I figured out, I think I know why. I think I fixed it, so we're gonna see today. But anyway, let's go over how this works, right? So, to begin, plastic first must be loaded in, right? But we first need to understand what is this machine and how it works. So what you see here is we have two chambers. We have this upper chamber, which is a continuous feed chamber. And then we have the chamber below it, which is the actual reactor chamber, right? Now, the reactor chamber is, well, occupied by these right here. And these are magnetrons. This right here is a magnetron. This is a microwave oven generator. This emits 2.45 gigahertz microwaves. This is what's in your microwave oven at home, and this is what's on my reactor. I happen to have 8 of these. I also happen to have 8 nuts because of these. So anyways, these magnetrons create the microwaves, and we have waveguides right here. And waveguides shoot those microwaves inside the machine, right? And so now the microwaves are inside the machine, and you understand that part. But let's back up. Let's rewind. Volviendo. So, going back to this, what we have is the continuous feed chamber at the top, but also the primary feed chamber. So when we want to load plastic into this machine to begin with, you see this right here. Hold up. Yes, this. This right here is actually connected to a shop vac hose, right? Which comes all the way back over here. And we have this shop vac, right? And so when I turn on my shop vac, I can now suck in plastic, right? From the plastic shredder. And then the plastic is going to end up getting sucked in to this chamber here. And what we have inside of this chamber are shaftless auger blades. It looks like a gigantic spring. And it will spin and rotate the plastic down, right? And then when the plastic is rotated down, it will then, of course, reach right here. And then it will fall into the main chamber, right? Once plastic is in this main chamber, when then, let's say we have everything ready, we turn the machine on, close all the valves and the ports, turn the machine on. Okay, once the machine is turned on, the microwaves start to heat up the plastic. But here's where things get interesting, because you would think, okay, if I go and put something in my microwave and try to, do microwave pyrolysis at home, it's not going to happen. I'm not going to make fuel from plastic. It's just going to turn the plastic into smoke and fire and poisonous gases, because you're just going to set the plastic on fire. Here's why my machine is different. My machine, for one, operates under vacuum. That means my machine is constantly being sucked 24/7 during operation, right? Constant suction force on my machine at all times means that, for one, no air is going to be introduced in the process as long as the machine is sealed. But for two, of course, it means that it's under vacuum, and being under vacuum means that having that constant suction force allows for the machine to not build up positive pressure which stops it from blowing up potentially, for one, or for two. And for three, the machine also operates with no oxygen, okay? So to start the machine, we actually pull a vacuum. We suck out all of the air from the machine and all the oxygen. And when there's no oxygen or air inside of a chamber, if you try to light something without oxygen, it will not catch on fire. You know, that's why if you have a candle and you put the cover over the candle, it's gonna extinguish it, because you need oxygen for something to burn and catch on fire. So instead of the plastic catching on fire, here's what happens, right? Instead, the plastic does not catch on fire and create smoke at all. It actually breaks the plastic back into petroleum. Those of you that did not know, now you know. This right here, El Plastico, plastic is made of petroleum. And this returns it to petroleum. So the plastic becomes a petroleum vapor, not smoke. Petroleum vapor, and that petroleum vapor comes up here. Then it hits these condensers, cools it down, and it becomes a liquid again. And we can literally see that liquid flowing when the machine is on. And it flows down, ends up in this keg here, right? And this is another condenser here, but that's for a separate part. So we get the plastic crude oil down here. You can actually see some in there right now. See freaking spiders. What? This is not the environment for a spider. Nonetheless, there's some in there right now. You see there's some in these hoses and stuff right now. Anywho, some of it needs further cooling to condense, and that's why we have this big Mac Daddy condenser right here, 8-inch condenser, 40-foot jacketed stainless steel coil condenser right here. And this is going to condense that petroleum vapor even further, because some of it always will be a vapor, and we end up using it as an alternative to natural gas. But we want to get all the moisture out of it first, so we have all of these condensers. That's what this freaking beeping thing is. It won't shut up. Goodness gracious, it's been beeping forever. But anyway, some of it ends up being natural gas. It goes into this recovery pump here, which sucks it in and pushes it out under high pressure. And that high pressure plastic made natural gas ends up in all of these tanks. And I have a demonstration for all of you. I have a demonstration. Because we can actually light this plastic made natural gas right now. What do I want to set on fire? Safely, of course. Let me get something I can... Oh, look, we have some cardboard right here. We will gladly get a piece of cardboard. And you see, this is the output end here. And so we'll just set this on these pavers here. So, you know, right now I have some plastic made natural gas from the last run. Oh, how could I forget? And of course, sorry, my apologies, everybody. This entire machine runs off of solar. All that you just saw is powered completely by the sun. El Sol. Completamente. Completamente. And so, when I make my fuel, since I am slave labor, since I'm black, it's $0 a gallon. You know what I'm saying? $0 a gallon. Because the machine doesn't have any consumables, you feel me? Consumables, you feel me? Paid $0 for it. So anyway, we'll turn this on, right? And then I'll light it. And this stuff burns so clean it's invisible, you know? But it's there. Can you see it? Yeah, you can see it a little bit. But especially once you take some cardboard to it, once it's already going, there you go. Plastic made natural gas. Look at that. Look how clean it burns. And, you know, some people do ask, and I don't blame you for asking, but are there any microplastics in any of my fuels? You know, gasoline, diesel, jet fuel, the crude oil, or the natural gas? No. For these fuels to even be formulated, right, the plastic is completely and chemically destroyed on an atomic level, and it's a permanent chemical change which destroys the hydrocarbon bonds that made it plastic and returns it into shorter hydrocarbon bonds that are that of petroleum. So therefore, this has zero microplastics. It cannot physically or chemically have microplastics in it. See, let me turn this up. See? And so the idea is this, right? I'll turn that off now. See, that thing is still beeping. That water chiller, man, I tell you. The idea is we take this plastic-made natural gas, which is a natural byproduct. Hey, what's up, Positive Being? Good to see you, man. It's been so long. OG. Look, Positive Being has been around since I was legitimately building this in my parents' backyard. Just this bottom chamber. This was the original Mark 4.5. Now it's Mark 4.55. Gosh. We need to just get to Mark 5 already, right? Because this is a completely different machine with this top chamber. Anyway, good to see you, Positive Being. Nonetheless, where was I at? I was at a Diddy party. I was at saying that we have the plastic-made natural gas here, right? And the idea is we take the plastic-made natural gas to heat this. Because it's a natural byproduct of the machine. What is this? This is the refiner. So you saw the plastic crude oil. It was like really dark, really dirty, right? Not baby oil quality. Well, when we put it in this thing right here, and then we use that heat to, make the crude oil boil in here, this is how you turn that plastic crude oil into plastiline, plastidiesyl, plastijet fuel. So this is the refiner. And this is literally the same process they use to make the fuels of this world. When they refine crude oil, it's called fractional distillation. So you see, we're just implementing old technology in new ways. That's all we're doing. And so, and then the microwaves are, of course, the star piece of this entire machine, because the microwaves are what allow this to run off a solar. Guys, I've been saying this for years. Because everybody always wanted to talk to me about some energy input versus output. And I'm like, guys, the reason I use microwaves is because one day we're going to run this thing off of nothing but the sun. And it doesn't matter what the energy output or input is. And it'll still be efficient, but it doesn't even matter because it's free. I'm out here in Alabama in August. There's plenty of sunlight. There's no shade around me. That's why I got my shirt off, because it's so hot out here. It's that hot out here. So all I got to do is set out the rest of my solar panels, build some mounts for them, get them off the ground. But right now, actually, let's go take a look. Let's take a look right now at, said, is it rentable? Are you for rent? All right, so this is the battery Evo Komodo. This is a 100 kilowatt hour battery. And these are the solar panels. These solar panels are not operating the best because they're on the ground. You see the grass is blocking some of them. I gotta fix all this nonsense. I got a whole bunch of other solar panels too that I gotta hook up. Hooking up solar panels isn't as straightforward as you think. Because if you try to hook up different types, things can get complicated and difficult. It's not, you can't just plug them all in, But anyway, right now, see, this is what I'm saying. These solar panels are messed up. I have a short, because I have about 8 kW of solar panels over there, and we have full sun right now, but there's only 2,000 watts going in. That's not right, right? This should be at least 8,000 or 9,000 watts of solar energy going into this thing. So I gotta fix it. I gotta figure out where the short is, all that nonsense. But it doesn't matter, because at the point is, regardless of what the solar panels want to do, this thing is still running off the sun. You see, I don't have a generator. There's no grid. There's no power lines. I'm out here off grid. And guys, this is the point. You need to understand, this is the point, because where plastic waste is truly the biggest problem, you're not going to always have a grid. You're not going to have a grid on the beach of Guatemala, You're not going to have a grid, in Indonesia or when you're in Senegal and you already are having rolling blackouts because the energy grid is that unreliable, and now you want to throw on a plastic to fuel reactor. Well, you know where all these places have in common? The sun. So we use the sun to turn plastic waste into fuel at a cost of, it's got to be at least less than $1 a gallon. I'm just saying. I guess we'll see the true cost. Here's the thing about the true cost. I don't even know what the true cost will be because, like I said, the machine has no consumables. I'm slave labor because I'm black. But if somebody were to be hired at, let's say, $15 an hour or whatever, what would the cost come out then? for like the cost of a machine. Because you know the machine is getting rid of plastic waste and it's creating fuel. So those are two pieces of value being created from the machine at the same time. You can't just look at the fuel and be like, okay, that's it. That's all the value. No, this is getting rid of plastic at the same time, which is the whole point of the machine. See, I don't care if we didn't even make fuel. I just want to get rid of the plastic in a way that's controlled. It just happens that we could take the plastic and turn it into something useful. Why not? Why not? Why not turn it into something that we actually can use? Something that's actually useful on a daily basis. That's how I see it, right? And so that's the real goal of the machine. Get rid of the freaking plastic without making microplastics, without making leaching plastics, without turning it into more plastic, because we got too much. This is see they want to say all that stuff is recycling, but tell me how it's recycling. You're turning one bottle into another bottle, but they don't tell you about all the microplastics that pollute the waters when you do that. Because they gotta use water in that recycling process, and it gets polluted with microplastics. My machine not only creates zero microplastics, but it destroys any and all microplastics. Any and all. They cannot exist in this environment. That's the whole point. That is the whole point of this machine. So, that's it. What was I? I think that was it. I think I finished explaining how the machine works. I mean, that's basically the main point. I've been saying that for years. It's always the same thing. No, I'm not burning plastic. No, there's no microplastics in the fuels. This is a permanent chemical change. The process of pyrolysis. And so, yeah, we're there. Oh, something I did want to talk to you guys about. Anybody in here, anybody that's mechanically inclined in here, I want to talk to you about this. I just added this top port up here. Look, it's putting a cap on the machine. Ha ha! Yo, that's funny. I've just put this top port up here, right? And what I want to do is I want to actually implement an air pneumatic cylinder at the top of that can like shoot down and press down into this area if this area ever clogs when we're trying to load in plastic. What do you guys think about that? Because I think that's a pretty good idea. Right? Like it's gonna come down. If this sight glass happens to clog with plastic like we see in the past, it's just gonna come down, break it up, then I could just shoot it back up. The only issue is that in order for it to work properly, I gotta do something so annoying to me, to nobody but me. And that is, I'm gonna have to completely reorient all of this to the front of this because I don't need the blades to get in the way of my little pneumatic. So, yeah, but I think that's going to be the best option. I was also thinking about implementing a vertical auger, but then I'm like, you know, that's going to be extra because then it always has to be on. Because if it's not on, then it's going to block plastic from falling down. And the plastic usually falls down just fine. It's just if I feed it in too fast, it'll get clogged, and then it causes a cock block with the entire machine. You said just use pressurized air. I just told you that my machine cannot have air in there. I just said that. We can't, that's the issue. We can't use air for anything, right? We have to keep the whole machine under vacuum, meaning I cannot open any ports, I cannot push in any air, I literally have to keep it under vacuum, I can't even touch anything in there. We have to have stuff that's completely airtight, screwed in, right? So, listen, I just told you we have to have no air in there, so I'll give you this pass. But if you dare, don't have your ears open to the knowledge I'm telling you right now. There will be much punishment. If you don't have your ears open, I will have your mouth open with all 8 of my nuts as punishment, because I'm not going to repeat myself more but a few times today. You got me messed up. See, that's the thing about TikTok. That's how you have to work with TikTok. Because people have you repeating something a million times. And there's no value if you have to say it 30 times. Alright, so what is it? 3:30? Alright, well, I think I'm about to head out of here. Yes, it's an actuator. It's a pneumatic actuator. That's exactly what we're doing. And it's already on the way. but I'm just gonna do that at the right time. But it'll be as easy as just replacing it with the flange that has that whole system built in, popping it on, boom. So, no. Yes, you're right. It's using air, but the air isn't getting in the cylinder. The air is just pushing the cylinder down. It's not putting air in the machine. You see, that's the difference. Breaking the suction principle throws off the air pressure balance. Huh? Okay. What's up? What's up? What's his name? What's up, Booling? So, anyways, I think I'm about to head back home. I'll be back out here tomorrow. It's a hard knock life out here, I tell you. Freaking working day and night. Plus I gotta drive like 4 or 5 hours to get back every time. Shoot. And that thing is still beeping. See, always freaking beeping, running its mouth, man. I tell you, can't do it anymore. But yeah, guys, we'll actually be back running the machine tomorrow. But I did just want to explain. I also wanted to see. I was testing. This live stream was a test, guys. This wasn't the real live stream because I wanted to make sure I wasn't gonna get banned again. Because TikTok kept banning my live streams every time when I was actually running the machine. Right? We almost had 10,000 people in here or so, and then it got flagged, and then they didn't let anybody else in. So then it just died, and I'm like, dang. But I figured out. I fixed it. Right? So we'll be back tomorrow. Well, everything looks good. And we're going to do a continuous run tomorrow. So thank you guys so much for your donations. Thank you so much for your support, your beliefs. And I'll see you guys tomorrow.